Hello, welcome to the Calc 2 class. I hope you guys have looked at the review document that I posted. Please try to kind of learn all the formulas that are in that document. Most of them maybe already you know. It's very important that you know your material from before in order to be successful in the next class in Calc. For example, to be successful in Calc 2, you have to know the material from before, which is algebra, trig, and Calc 1. So in Calc 2, we will cover pretty much from chapter 5 through chapter 11, excluding chapter 9. And so let us start with chapter 5, which is actually something you have seen before in Calc 1. And we will review few sections, 5.2, 5.3, and 5.5 from chapter 5, and then we will move on to chapter 6. So 5.2, if you recall, dealt with definite integral. So what is a definite integral? Well, it is written in this form. So this is the way it is written. But what does it represent physically? It represents the area of the shaded region. What shaded region? The region which is given by the or which is bounded between a and b on the x-axis, and a function f of x. So it is bounded above by the function f of x and below by the x-axis, and on the sides by the lines x is equal to a and x is equal to b. So this is the region whose area is given by this definite integral. So note here this the function is above the x-axis here. So when the function is above the x-axis, then this integral gives us the total area of the between the function and the x-axis. So how did we estimate this sum? So if you recall, in Calc 1 you learned that we can estimate this area by using the Riemann sums. So what were the Riemann sums? You must have learned two types of Riemann sums. One is the left Riemann sum, and the other is called the right Riemann sum. So what are those? Basically, the left Riemann sum uses the left endpoints and the right Riemann sum uses the right endpoint. So what did we do? We divided the subinterval, the AB, the interval AB on the x-axis into subintervals. How many subintervals? Well, that depends on the problem, but normally we say n subintervals. So let's say if you have these subintervals and you use the left endpoints, so you will be using the height of the rectangle from the left. So then this area of these rectangles, that will be the ln. That will be the left Riemann sum, or the Riemann sum with n subintervals using the left endpoints. And the formula that we use for that is given here, which is delta x times f of x naught plus f of x1 plus dot 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 plus f of xn minus 1. So notice here we start with x sub 0 and we go up to 1 less than the last endpoint, which is x sub n. And in the same way, we can also estimate this area or this value of this definite integral by using the right endpoints of the subinterval. So how did we do the right endpoints? Well, we have the same situation. We have the function and then we divide it into subintervals. And now this time we will be using the right endpoint. So we will be using the endpoints from this side. So this is area is the estimate of the definite integral. So in these formulas, so notice here in Rn, the Riemann sum with n subintervals using the right endpoints, we have delta x, and we start with f of x1 and go up to f of xn. So we start with the second endpoint, second point on the subinterval, and we go to the last, or we can say tick mark. So how do we calculate those? First thing, delta x is the width of each subinterval, and its formula is, or is calculated by this formula, b minus a over n. So how do we find these x sub 0, x sub 1, and so on? So remember, x sub 0, the first tick mark is always going to be your starting point, your a. And you can find the next tick mark or next endpoint by adding delta x to the previous x point. So here we find x1 by adding delta x to the x0. We find x2 by adding delta x to x1, and so on. So this is how we can find the estimate of the integral, or the definite integral. So looking at an example here, we have used the Riemann sum with 3 subintervals. So what does that mean? It means n is 3. And so our f of x is 1 over x, our a is 3, and our b is 5. So now the first thing we need to do is find our x sub 0, and note here, because n is 3, so we will go from x0 to 3, x3, and so there will be 4 tick marks. So how do we find? We start by finding delta x, which is b minus a over n. So in our case it will be 5 minus 3 over 3, which means 2 over 3. So x sub 0 will be 3, x sub 1 will be 3 plus 2 over 3, which is 11 over 3, and x sub 2 will be 11 over 3 plus 2 over 3, which means 13 over 3. X sub 3 will be 13 over 3 plus 2 over 3, which means 15 over 3, which is 5. And this will always happen. So this is something you should know, that always if you did your calculations correct, then the last one will come out to be equal to b, and the first one is always going to be a. So this is your a and this is your b. Now we are to find the Riemann sum using the left hand point. So it means we need to basically find L sub 3. So in order to do that, we go delta x, and the formula says f of x sub 0 plus f of x sub 1 plus f of x sub 2, and now we stop. Although we have one more tick mark, x sub 3, but we are not going to use that, because if I put f of x3 here, then I'm adding 4 terms, and 4 terms means I'm using 4 rectangles, which is not what is required, because there is no 4th rectangle here. There are only supposed to be 3 rectangles. So we have to stop at f of x sub 3, and that's what it meant here when we said x of n minus 1, that 1 less than the last. So n is 3, so the n minus 1 will be 2. So now we just plug in the values. So the delta x was 2 over 3. F of x sub 0, now x sub 0 was 3, so f of x sub 0 will mean f of 3. So if you want, you may first write that, or you can directly do that. So this will be 1 over 3 plus, So f of x1, so x sub 1 is 11 over 3, so 1 over 11 over 3 will be 3 over 11, and then plus f of x2, so x2 is 13 over 3, so 1 over 13 over 3 will be 3 over 13. Now if the question tells you to get the answer in decimal, so then you can just plug it in your calculator and get the decimal answer. But if it doesn't say that, then you should only get the answer in terms of the whole fraction or whatever the form it is in. So let's add these. Let me put them in my calculator, and I am getting 2 over 3 times 501 over 143. So when I multiply by 2 over 3, I end up getting 334 over 143. So that is my answer. And as I said, if the question says get the answer in decimals, then you have to find the whatever the question gave you or told you, however many decimal places you have to go to. So let's say if we have to go to 3 decimal places, then the answer will be 2.336. Okay, so this is how we do the approximation of with the Riemann sum. So what is the relation between this Riemann sums and the definite integral? The Riemann sum is an approximation of the value of the definite integral. So if we take the limit of the Riemann sums with n going to infinity, in other words, if we make the number of subintervals too large and like going to infinity, so in other words, our rectangles are becoming very, very thin, then that will give us the area of the total area, which is the value of the Riemann sum. Now in general, if we don't care whether the function is above the x-axis or below the x-axis, then the definite integral gives us something called the net signed area, which means we can have positive or negative values of the area of the definite integral. Well, we cannot have area to be negative. Area is always positive, but the definite integral can have a negative or a positive value, or depending on the situation. So in other words, what happens in this case is that if you have a function which has a part above the x-axis and a part below the x-axis, then when you are finding from A to B, so let's say this is A and this is B, then let's say this area is called A1, this area is A2, and this area is A3. So note here, we are finding the area between the function and the x-axis always. Then the definite integral in this case will be equal to A1 minus A2 plus A3. Why? Because A1 and A2 are above x-axis, so they are positive. The area below x-axis will be subtracted. So now we are given an example here. So we are given the graph of a function f, and we are asked to find these definite integrals. So first, the definite integral from 2 to 4 f of x dx. So from before, remember what this gives you is the area or the net signed area. So in other words, area between the graph and the x-axis. So from 2 to 4, so this is your 2 and this is your 4, and you can see that between 2 and 4 the function is above the x-axis, so we will have a positive value of the area. In other words, we just find the area of this region. Let's call it A3. So this is just a rectangle, so this will be A3 which is equal to, sorry, it's just a triangle, so formula for area of a triangle is 1/2 base into height. So 1/2 base is 2 and height is 2, so 2 times 2, so the answer is 2. Now in order to find the second definite integral, which says from -3 to 4 f of x dx, we have to go from -3 to 4. So we notice here that we have kind of three areas that we need to calculate. So we will be calling this little triangle, its area to be A1, and the triangle over here between -2 and 2 to be A2, and A3 we already calculated. So we will say that this thing is equal to A1 minus A2 plus A3, where A1 is 1/2 times 1 times 1 minus 1/2 times. So if we calculate the area of the triangle which is below the x-axis, so its width or base is 1, 2, 3, 4, and the height is 2, and then plus the A3 we already calculated, so I'm going to use the value. So we are getting 1/2 minus 4 plus 2, or 1/2 minus 2, or 3 minus 3 over 2. So that is the value of the definite integral. So let's look at some properties of the definite integrals. So there are other properties, but with the calculations, but also we have this situation that if we have to calculate the definite integral between a and b, and then we have somewhere in between a c, then the definite integral from a to b f of x dx will be the same as the definite integral from a to c plus the definite integral from b to c to b. Also recall from before, the definite integral from a to a is always 0, because basically this is saying the area under a point. And then if you have to invert the limits of integration, then you end up getting a negative sign in front. So using this property, we can try solving the next problem. So it is saying, so from -2 to 1, the definite integral has the value 5. From 3 to 5, it has the value -2. And from -2 to 5, it has the value 4. So it says find the value of the definite integral of f of x from 1 to 3. So if you notice here, if I draw a line, we are starting from -2, we are going up to 1, then we have from 3, so we have this value, and from 3 to 5 we have this value. Also we know the value of the total, so what is missing is this one, so and that's what the question is asking. So by the properties, we have that the value from -2 to 5 f of x dx can be broken down as value from -2 to 3, sorry, -2 to 1 f of x dx plus 1 to 3 f of x dx plus 3 to 5 f of x dx. So we already know the value on the left, which is 4, and the value of this first one is 5. The value of the second one is what we want to find out, and the value of this next one is -2. So just add, do your algebra, and you will notice that the value of the definite integral from 1 to 3 comes out to be 1.